Hello, let's take a look at Leetcode programming problem number 120, triangle today. So the problem is as follows. We are provided with a triangle of integers and we have to find out the sum of the minimum path in it. So basically what this means is if you look at this example that they have provided, so in this triangle, this is the triangle. So the minimum path sum is you go from 2 to 3 to 5 to 1, which is 11. And the rule for traversing this triangle is that when you move down a row, and if you are at the ith index, so you could move down to ith index in the row below it, or you could move down to I plus first index. So these are the only two ways through which you can move down the triangle. So I am going to discuss a recursive approach for solving this problem. Let's take a look at it. So this is the same example I have taken in over here. So in this, if you see, we will always start with the root. So root is always going to be the part of the minimum path sum. Now when we are at 2, we have two choices. So we can either go to 3 or we can go to 4. And then let's say when we go to 3, again we are presented with two choices, either to 3 or to 5. Similarly, we can extrapolate it to the lower levels. So as you can see, this gives an intuition of a recursive subtree emerging. So it would be something like you start with 2, then you have two choices, either choose 3 or 4. Then at 3 you are again presented with two choices, either go to 6 or 5. With 4 you again have two choices, either go to 5 or go to 7. And then when you are at 6 you could go to 4 or you could go to 1. From 5 you could go to 1 or you could go to 8. And from 7 you could go to 8. Sorry, so this is 5 again. So from 5 of course you can go to 1 or 8. And from 7 you could go to 8 or 3. So these are all the possible paths. So if we compute the sum of each of the path, for example, let's take this first path. So this path is this way. So this is 2 plus 3 plus 6 plus 4, which is 5 plus 6 11 plus 4 15. So this is equal to 15. We can consider some other path. Let's say this one. So in this case it is 2 plus 4, which is 6, 6 plus 7 13, 13 plus 8 21. So if we find out all the sum of all the paths from the root node to the leaf nodes at the bottom, we would then be able to find out which one is the lowest sum. So in this case it would be basically if you go from 2 to 3 to 5 to 1, right? So this would be 11. So this way we can formulate a recursive approach wherein for each node we go to a level below and follow both the paths and find out the sum. So this is going to work, but it is not very optimal because you are going to do a lot of repetitive computations. For example, if you see in over here, you would see that this computation for 5 is being done twice. So this, which is no longer needed. What we could do is that once we have computed the minimum path from a triangle rooted at 5, we can just use it whenever we are at the root 5. I mean, we do not need to compute it again. So for that we can use a technique called memoization. So it is basically a map that we would maintain, and in that map the key would be the root node. So the key would be the root node, for example 5 in over here, and the value would be the sum of the minimum path from it. And when we are doing this recursion, so when if we find some node which is our root and it is already present in the memo, we just return its value. So this gives us some performance optimization. So this is essentially a top-down recursive approach with memoization technique. So if you want to check out the programmatic solution for this problem, please check the link that I have added in the description. Thanks for watching.